Good morning for all the assistants of this event. Welcome to CIDETEQ. We're going to take a minute for presentation of the Internal Protection Brigade of CIDETEQ. We can identify us by the color of the vest we're wearing. We show you with the compañeros. If you need assistance for emergency, you can contact us immediately. We can share now a little video, audio of safety. We can play the audio, please, for the indication of safety.
Welcome to CIDETEQ. Your attention, please. In case of evacuation, the emergency exit is through the door where you entered. We ask you to do so in an orderly manner and following the instructions of the staff in charge. Remember, do not run, do not shout, and do not push.
Thank you so much for your attention. And we are, in case of emergency, near to this city. Thank you.
Okay, so thank you very much for being here. My name is Juan Manriquez, and on behalf of our authorities, it is my pleasure to say hello and welcome to the second national meeting of Advanced Oxidation Processes. Allow me to ask the name or some professor that will carry out the opening of this event. Professor Erika Bustos, Professor Dr. Angela Maria Stortini, and Professor Dr. Hugo Olvera Vargas. Please come with me to the front of the event. And it is for me a pleasure to say hello to our authorities, Professor René Antaño López, Professor Fabricio Espejel Ayala, and also Professor Maria Yolanda Vidal. So please, Professor Erika, give you some questions, some words.
Oh, thank you so much. Well, in representation of our authorities here in CIDETEQ, welcome everybody. We are very happy because you are here, and we compare different researchers focused on advanced oxidation processes. This is the first time that we join different projects, in this case Erasmus Plus, with the collaboration of Professor Angela, and the organization of CIPOA, with collaboration with Professor Hugo. That's why we are here. And welcome everybody. We have some short visit to the different facilities today in the afternoon. We have different groups that we organize, and we are very happy that you recognize different areas here in CIDETEQ. In other case, well, you know that we have the program in the formal site of this event. We have different oral presentations. We have 2 oral presentations each day, and well, in the last day, only 1. And the different poster presentations. You know that we will have a champion. We will give you some gifts for the first, second, and third places. So enjoy with that champion. And now, well, any question on something that you want to know about CIDETEQ, please comment to us. And well, we'll continue with Professor Angela.
Thank you very much, Erika. For me, it's a pleasure to be here. Good morning, everyone. And this is a good occasion to remark the collaboration in the frame of Erasmus+. We got 2 projects from 2019, and this is the second one. We are at the finish, and we, of course, host some of your students, PhD students, and for us, it's been a pleasure stay with them in lab. And of course, they made a very great job and with very good results. Thank you very much.
Thank you. Hi, everyone. Welcome to CIDETEQ. Welcome to the second national meeting on advanced oxidation processes. It's a pleasure for us to have you here. As Erika already mentioned, this event is about advanced oxidation processes, research on this beautiful area of research about taking care of our environment. We really hope that you will enjoy the event. You will enjoy CIDETEQ. Thank you, CIDETEQ, for bringing this event. Thank you, Erika and Juan, for bringing the event to CIDETEQ. It's really a pleasure and honor to be here. The first edition of this event was in 2023, if I'm right. It was in the Institute for Renewable Energy in Morelos, and it was a big success with over 40 people attending the meeting. And now here we are in the second edition, and I'm very grateful to Juan and Erika to bring it here. Welcome everybody and enjoy the event. Thank you.
Please, please, please. Okay, we have some videos in order to present our institutions. Obviously, CIDETEQ and Caposcari University, and also the IER, the Institute of Energy in Cuernavaca, Morelos. Please, can you project the videos?
Every scientific breakthrough begins with a question.
How can we make our environment cleaner? How can we ensure water quality?
How can we promote sustainable industrial growth? How can we leverage technology to promote social well-being?
In Querétaro, Mexico, there is a place dedicated to answering these questions through science and technology to provide real solutions. That place is the Center for Research and Technological Development in Electrochemistry, CIDETEQ. Our core focus is electrochemistry, the science that transforms electrical and chemical phenomena into knowledge and technology, from water treatment and clean energy generation to materials protection and the development of sensors for healthcare. Founded in 1991, CIDETEQ, part of the Ministry of Science, Humanities, Technology, and Innovation, and is dedicated to promoting scientific and technological research and development in the country. To achieve this, we generate knowledge, develop cutting-edge technology, train highly skilled specialists, transfer solutions that strengthen the productive and social sectors, and provide specialized laboratory technology services that support quality and innovation across multiple sectors. CIDETEQ has highly qualified scientific and technological staff, as well as laboratories accredited under international standards, enabling it to deliver reliable, high-quality responses to current challenges in the energy, health, water, and environmental sectors. We offer specialized technological services in chemical analysis, corrosion, vibration, weathering, and materials characterization, geared serving key sectors such as automotive, aerospace, environmental, and healthcare. We implement research and technological development projects in areas such as water purification and wastewater treatment, clean energy generation, including green hydrogen, and the production of antibacterial materials and electrochemical sensors, promoting sustainable, high-impact solutions. Through our continuing education programs, we offer specialized courses taught by expert staff with a practical focus and aligned with the needs of the productive sector. Furthermore, through our master's and doctoral programs in electrochemistry and environmental engineering at CIDETEQ, we train the next generation of specialists in research and technology development, integrating them into high-impact social, industrial, and environmentally friendly projects. CIDETEQ serves as a bridge between the productive sector and science. We work every day to promote scientific sovereignty, foster sustainability, and transform knowledge into well-being for society as a whole. CIDETEQ, committed to science and technology for society's well-being.
Empieza tu propio camino hacia la grandeza. Estudia en UTEL Universidad. Ser los mejores requiere de todas nuestras energías. El Instituto de Energías Renovables de la Universidad Nacional Autónoma de México, UNAM, se ubica a la vanguardia en cuanto a los servicios que brinda en las áreas académica, de investigación, tecnología, ingeniería, asesoría, evaluación y gestoría. Su oferta académica comprende la licenciatura en Ingeniería en Energías Renovables, maestrías y doctorados del Programa Nacional de Posgrados de Calidad, servicios educativos complementarios, servicios de capacitación especializada, servicios de investigación, el Instituto de Energías Renovables lleva a cabo diversos proyectos de transferencia tecnológica, además de distintos desarrollos tecnológicos. En cuanto a los servicios de laboratorio, contamos con el Laboratorio Nacional de Sistemas de Concentración Solar y Química Solar, y el Laboratorio Nacional de Innovación Fotovoltaica y Caracterización de Celdas Solares. Asimismo, todas las áreas de investigación y desarrollo tecnológico cuentan con sus propios laboratorios internos, plataformas y plantas. Nuestras capacidades en materia energética se enfocan a los rubros de análisis y caracterización de materiales y tecnología, además de ofrecer capacitación y consultoría energética. En el rubro de servicios a detalle, brindamos servicios de ingeniería, preparación de bases técnicas y evaluación de propuestas en licitaciones. servicio de gestoría para diversos proyectos dentro y fuera de México. Servicios de auditoría energética y de evaluación técnica. Estudios de factibilidad e implementación de eficiencia energética. Planeación energética. Asesorías especializadas. Y talleres especializados. En síntesis, el universo de servicios que ofrece el Instituto de Energías Renovables de la Universidad Nacional Autónoma de México concentra todas nuestras energías para mover al mundo en pro del desarrollo sustentable.
Okay. Thank you very much. So this is all the facility that our institute can be used for all of you, and we are open to collaboration. And finally, I would like to say that we can start this event, and it is a pleasure for me to introduce to Professor Hugo Olvera, because he is our first chairman. Thank you very much. Hugo, it's yours.
Thank you. Thank you very much. Welcome, everybody. And now we're starting with the program. Now I think you will introduce Angela. I think we can start with the program. It will be our first invited speaker of the event. And I will let Erika to introduce her, please.
Well, yes, the presentation of Professor, please. Well, for me, it's a pleasure because just the last week, we remember that we have 10 years that we knew in a Congress. And after a coffee, we began with the different ideas, how to collaborate between us, the different institutions, and how to interchange students. And fortunately, we had some interchanges between the PhD students from CIDETEQ and to Ca' Foscari. Well, Professor Angela is a researcher in analytical chemistry at the Department of Molecular Science and Nanosystems in Ca' Foscari University of Venice, Italy, where she teaches analytical chemistry and instrumental analytical chemistry laboratories and serves as scientific coordinator of the educational analytical chemistry laboratories. She holds a degree in biological science and a PhD in environmental science, focus in environmental chemistry, at the University of Florence and Pisa, respectively. With more than 30 years of research experience, her scientific activity spans environmental chemistry, analytical chemistry, marine chemistry, and environmental electroanalytical sensing. Her research has contributed to the understanding of air-water interface processes, marine surface microlayers, atmospheric particulate matter, trace metal cycling, and environmental pollution, as well as to the development of innovative sampling methodologies for the surface microlayers and electrochemical sensors, based on nanostructural materials for environmental monitoring. Her current interest focus on environmental electrochemistry, advanced sensing technologies, and the detection of emerging contaminants in water. Throughout her career, Dr. Stortini has participated and coordinated numerous national and international research initiatives, and including the Italian Antarctic Research Program, Interreg projects in the Adriatic region, PRIM projects, Erasmus Plus collaboration with CIDETEQ, and Horizon Europe activities, Pro Clean Lakes Mission Project, and others. She has served as scientific coordinator during several Antarctic experiments and has promoted international cooperation in environmental chemistry and electroanalytical chemistry through teaching, research, and academic exchange programs. Beyond research, she is actively engaging in science disseminations, student monitoring, and academic orientations activities. She has collaborated with international funding agencies and scientific organizations as evaluator, including the science funding of the Republic of Serbia, and serves as reviewers and guest editor for several international scientific journals. Dr. Stortini is the author of 47 peer-reviewed scientific publications, a book chapters, and numerous conference contributions. Her works has received more than 1,500 citations and achieved an H index of 20, reflecting a sustainable committees to the advancing environmental and analytical science through research, education, and international collaboration. Well, additionally, I want to comment you that tomorrow she will show you different ideas to have the Marie Curie scholarship with the different institutions. So it's interesting to be there tomorrow. Thank you. Welcome, Professor.
Thank you very much, Erika. And okay, thank you very much. And I want to start with the presentation of my group. It is a little bit different with respect the theme of meeting, because oxidation, of course, abatement, of course, reduction of some pollutants or something else. We make sensing. And for us that make sensing, no better abatement processes could be helpful in the development of sensors. This is my group. You see, I here with my colleagues, and I want to say to you some of us. Let's remember what the Gold Book of UPAC says about sensor. Transducer type device that responds to a specific property of its surroundings or to a coming stimulus by a visual readable change, and it stays or by generating a signal that can be read by an observer or instrument. This is a very clear definition about sensor. So, what is our work at the moment and what we want to do? We are going toward sustainable and cost-effective electrochemical sensors. We want to overcome the typical setup 3 electrodes that in electrochemistry is usual for make studies and, of course, measurements on substances. Essentially, we want to work in preparing portable sensor, cost-effective, sustainable, and added with the graphene, carbon nanotubes, MOS, metallic nanoparticles. In practice, nanoparticles and nanostructures that increase or help us to obtain a good signal. We have essentially at the moment, two methods to obtain this kind of cost-effective electrochemical sensor. First of all, laser scribing. We obtain by such treatment a graphitization by a CO laser, and we work in supports like polylactic acid or cellulose paper, so simple. And the second one, inkjet printed. It means intelligent inkjet that could be useful for detections of some analytes, some enzymes, or some material or organic material. In practice, you see in the second one, in the inject printing, you obtain a structure with an inject with metallic nanoparticle, polymers, enzymes, what is necessary to obtain a response. Taking the first case, like described electrode, we know that when we treat one card hold directly, we obtain a very high porous electrodes. This, of course, who makes electrochemistry knows that increase the active area of the surface that interact. And they has been used, for example, for the detection of histamine in some kind of food in the degradation, like chicken breast, like Parmesan cheese or tofu. They are very effective. And of course, when you treat in this way that you see here, you obtain a good response about histamine for this application, of course. In the other case of our smart inks, what we have an ink that, of course, have to be created with receptors, and of course, we have to ink binders, we have to consider ink binders, electrocatalytic properties of them, nanomaterials of biomolecules entrapment, and enzyme stabilizer. It is quite different with respect to the first picture I put to you. So in this case, you see we have some kind of structure that, for example, let us, in some cases like nanoflowers, nanosheets, or something else, let detect what we want. And our objective is obtain a kind of printing sensors with the cost less than 10 cents of euros, which is very, very good idea. And of course, it is very sustainable, because if you want to buy a kind of imprinting sensor, you know better than me, if you work with this kind of sensor, that they cost very well, very much. So applications of this kind of sensors, for example, in biomedical field, it means wearable sensors for proteins, hormones, metabolites, neurotransmitters, ions, or for viruses. It was one of the results we obtained, especially after COVID, that we know that everybody was working so hard to obtain a kind of surface able to detect viruses in a very easy and reliable way. And the third argument, for example, sensors for neurodegenerative disease, in which you use microneedles for make a contact with the person has to be detected some kind of neurodegenerative enzyme or something else, and you see that you obtain a very good response, and the results give us very good scenery for the detection of neurodegenerative disease. This is another approach, quite different with respect to the approach I show you now. In the approach I showed you before, of course, sensitivity is the most important thing for detection of some kind of neurodegenerative enzyme or some kind of product of metabolites. In this case, you know, when you have to measure in human fluid or in organic fluids, detection of ions are not so simple. are very complicated, especially if you want to detect sodium and potassium. It's not, even if you have the most sensitive sensor, it's not so easy make a differentiation about both signals. So what is the approach? Here, the approach is create a fingerprint. Create a fingerprint, use neural networks, artificial intelligence, and make such kind of measurements. For example, you have a setup of 120 electrodes, 1,000 response of each solution. Each platform realized 3 solutions, and each solution analyzed with multiple platforms. You obtain a database divided into the training of validation, test, and sets. Of course, you use ferrocyanide, and the idea is obtain fingerprints, of course. And we are moved also to ammonium and the calcium for another kind of detection. No. And this is our group. And as you can see there, for our work is really important, have a lot of collaborations, because, for example, the first group is they give us the material like graphene oxide or some modified graphene oxide material, some other kind of like Chic Biomagune give us, for example, or support us in the development of ink for the preparation of this kind of platform I showed you before. And this is our colleague, Giulia Moro, that is working together with me also in PFAS sensing, peptide biosensors, synthetic peptides, and selective bioreceptors, pesticides, portable optical platform, and electrochemical sensors. My lab, fundamentally, is focused on health and environment. Wearable sensors and sensors, portable sensors, or such kind of particular sensors for the detection of analytes in environment. So, and here some very brief example of our publication. As you can see, we developed also sensors for the detection of nutrient. We work with plasma for the activation of such kind of sensors. We detect, for example, lead in olive oil. It is possible sometimes, unfortunately. And in some cases, we have to be very careful. And electrochemistry is also useful for this kind of detection. Electrochemosensors for PFAS, or, for example, other sensors for glyphosate, and of course, with different criteria, like a paper-based, for example, or graphene oxide. It depends on the support you want to use, of course. Our expertise is, of course, in health that you saw before, but also in environment, food, and cultural heritage. I want to introduce you a project, an European project, where we are so active. We won this project a couple of years ago, and you see in Italian, I'm sorry, because this is the slides for disseminations for students. Because one of the requests of European community is that your work, of course, is useful for develop of science, for make science, obtain very good results and very good application, but with the condition that your science could be spread to people, citizens, students. Every part of the population have to be involved in this kind of activities. And the project is ProClean Lakes, which is a project that wants to recover lakes in Europe. It's based on lakes that has been recovered, and they are just demonstration sites and sites for the requirement for very high pollution that have to be monitored in the time. Just to give you an idea, which is the situation in Europe. We have a very good quantity of lakes in Europe. The great part comes from deglaciation, of course. And if you see here, Finland has the great part of this lake. But if you see this graph, what you see? The 25% is considered good, but the 75% is not good. And it is very mandatory for us do our best in this project. This is a mission project. What means have a mission project, an European mission project? We have to give a protocol and test a protocol for best practice in the recovery of lakes and, of course, for the management of a lake. Because lake means in Europe, especially in the north of Europe, the life means tourism, means agriculture, means support for many activities. So it is the time to recover our lakes in Europe. What are the most very heavy resources that give us bad lakes? Agriculture, invasive alien species, forestry, climate change, birds for immigration of birds, urbanization, and so on. And one of the applications in lakes are the natural-based solution. What means? Means that we recover the lakes, use natural-based solution. You have to reconstruct barriers, the sediments, also the area around the lake, because in great part of these cases, the lake has been completely depleted. So it is very hard to do, but you project to reconstruct the lake. Our rule in this project is develop sensors. In fact, this is a very curious project because there is everybody inside. Chemists, biologists, administrators, economists, because a mission project has the objective to push again this reality and give again good conditions for population. For example, there is also incubator for enterprise, just to support people that want to have or open a sustainable enterprise in such areas. Taking our job, for example, you see we are here working for PFAS like FOS and FOA, glyphosate, AMPA, which is a metabolite, and microplastics. Microplastics, but be careful, not microplastics of big dimension, but microplastic that goes inside of the life cycle and individuals. So in practice, we have built connections, create impact, and of course, we have to work with institutions, we have to collaborate with colleagues, we have to stay inside a European project, and of course, we have to communicate with students, with population, and, for example, give origin to the citizen science, which is the most requested by our European community. Now I want to move in a very electrochemistry subject, which is the work that Lupita made together with me in Italy. And it is the development of liquid crystal template silver electrodeposits for the electrochemical detection of alloacetic acids. Alloacetic acids, together with trihalomethane, are two products of the disinfectants in the water. Disinfection byproducts are, of course, a very big problem, and there are two main factors to obtain them. First of all, the use of disinfectants with chloride, of course. The second one, the natural organic matter, which support the transformation of this kind of products in disinfection byproducts. And they are very not good for the health and potential toxic products concerns, and of course reliable potential toxicological concern, and reliable monitoring is essential in this case. For example, in Venice, there are many plants that has changed a little bit the disinfectant, but chloride is always, even if in less amount, is always present. And some limits has been indicated by WHO, EPA, European Community, and as you see, they consider, for example, the sum of 5 of them, like monochloro, dichloro, trichloro, alloacetic acid, and the bromide, the monobromide alloacetic acid. Let's see and make just a comparison with the analytical classical methods. From one side, you see conventional methods, you what need derivatization required, multi-step sample preparation, expensive instruments for measurements, centralized laboratory analysis, time-consuming workflow. In the other side, what are the limitations? Matrix interferences in the electrochemical detection. Electrode fouling, which is a very big problem if you want to detect by this kind of support. Signal instability, limited reproducibility, and selectivity. But in every case, real sample complexity, it is a very important condition that sometimes could be not helpful even for both this method. In every case, what we do, silver used as an electrocatalytic material. As you know, if you modify a surface, you obtain, of course, an increase in an increment of the signal, and obtain, of course, a good response about the presence or not of the analyte you want to study. So why silver? Even in literature, some persons or some authors say that is problematic and or not. First of all, silver has a strong catalytic activity toward halogenetic compounds. Surely, it works. High conductivity, surface-sensitive electrochemistry, morphology-dependent behavior, and I can ensure you that it is. And, of course, less expensive with respect to palladium or platinum and so on. What is the way we follow to obtain such kind of nanostructures for the detection? We use surface self-assembling micelles-like structures. Then you move in the liquid crystalline phase. In step 3, you obtain the electrodeposition of silver, of course, by reduction. And then you remove the template and obtain the nanostructure you see in the image before. In practice, we prepared this kind of nanostructure in a gold support after silver electrode deposition. We made characterization, and of course, we made measurements of these three halogenates, that is monochloride, dichloride, and trichloride. What was our objective? Know how resistant was the structure and how efficient was the structure in give a response. In fact, we move in the concentration range between 5 to 1,000 nanomolar. Every electrode was used 5 or 6 sections, starting from 5 micromolar to 1,000 micromolar, all completely, included also blank measurements. And we use cyclic voltammetry. And as you can see, I want to show you this. The structure is itself a nanostructure and very organized in a very complex way and in very units, or who knows, also porous. I should see better in some analysis I will do in the next weeks to know exactly how these structures, small structures, are organized inside. In every case, electrochemical analysis and also surface area comparison give us a good result, and of course, template of silver deposit exhibit enhanced ruggedness, porous architecture, and expanded electroactive area. Let me show you better the image you see as I report here. It is very complex and at the same time very organized structure. Oh, pardon. What was my first surprise when I made measurements, together with Lupita also? If you see this, these are 7 blanks of this electrode, perfectly overloaded, one over the other. For me, it was impossible to believe, because usually in electrochemistry, you have to wait time, you have to remove oxygen, you have to have many factors to obtain a good result. Instead, in this case, I had a very good blank with signals that were very, very nice. And then we move to the measurements of the monochloride, dichloride, and trichloride. Data are still in processing. This is just an example about the response we obtain. As you can see, the first peak for monochloride, you obtain this, and the reduction, it is around in minus 0.8. And this is the part for the addings from 10 to 100 micromolar, and this one from 100 to 1,000 micromolar. Let's see the second one. As you can see, in this case, you obtain also the 2 peaks for the reduction of the molecule, and of course the halogenation of our dichloroacetic acid. Even for 100, 10 to 100, and 100 to 1,000. No. 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 Excuse me, but I don't know why. No. I don't know why it not move. No, yeah. Okay. Okay. This is the work that specifically I did with Lupita, with trichloroacetic acid. It was very, 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 no. It was very important for us. And what you see there in this calibration curve are the standard deviation of all measurements we made time by time, okay? First section measurement, second section measurement, and this is the standard deviation we obtain from these measurements with trichloroacetic acid. For us was very important and impressive because results like that was not easy to obtain. Okay. Then we want to compare how much, what was the amount of silver we put on the gold electrode. And make a comparison because, as I told you, fouling is one of the bad things that you obtain if you work with some deposition of silver or some kind of metal else. And if you see here, you can see the comparison of silver deposit and silver after use. The difference is not so high because we obtain a kind of protocol to keep this silver and obtain good results for have a good structure and of course avoid fouling. And here you see some of the load and logs that we make a first quantifications of course, and some calculations about what we obtain. And it's clear that we have to work, but we have to think about new solutions for this kind of detection. In practice, liquid crystal template is able to control silver nanostructuration, enhance, of course, the electroactive area for the catalytic of monochloro, dichloro, and trichloroacetic acids, and they are a promised and robust structures for their detection. And I want to show you, this is our group. Again, here it is Juan, Erica, and Lupita, and a student that support us during the preparation of these electrodes. And I want just to finish, give you some idea about what was the work of your student in our department. We had in December of 2025 a meeting in Bologna. What means the title? Sensors and biosensors as strategic instruments for health, environment monitoring, and food security. And as you can see, she is Lupita. She made of course, the work I showed you a few minutes ago. And she focused her attention also, in particular, in alloacetic acid. But the second one was Diana, what come to my department and stay in my lab and she worked with glyphosate detection with the platform she developed during her PhD. And it, for me, was a very exciting experience because they both are very good students, very clever and very also human, not only science, also human. And it is very important when you share your time in lab day by day, and especially when you are in moments with difficulties or some problems to define. When you see a person that support you in this way, this is very nice. And of course, take-home message. Portable electrochemical sensors are more than analytical tools. They are strategic, of course. A deep understanding of human being and environmental process enables the development of smarter, more reliable, and more impactful sensing technologies for health and environmental monitoring. You imagine if you have to make measurements with very big and very expensive instrument. You cannot design a kind of strategy for make some kind of screening, and of course to avoid to spend so much in your, and this is one of the objectives of the European community, of course. And by bridging of environmental science, education, innovation, entrepreneurship, and citizen engagement, sensors become powerful drivers of sustainable development. Thank you very much. Excuse me.
Thank you, Professor Angela, for this presentation. Actually, analytical chemistry is a fundamental part of research on advanced oxidation processes, because we do a good part of the research on AOPs involves wastewater treatment, water quality, air quality, even soil. So analytical techniques for the analysis of all these pollutants is like fundamental in this research. So do you have questions in the audience or comments? We have a question over there, please.
Thank you, Professor Angela. My question is from your first presentation. If there are any limitations when using more amorphous materials, for example, activated carbons?
Yeah.
For printed electrodes.
You mean in what sense exactly?
Print the screen printed electrode with amorphous material, for example, activated carbons.
Yeah, okay, I understood. To be honest, at the moment in the lab, we are concentrated in this hypothesis. We don't, or we are thinking about activated carbon, of course, for the surface. But in my opinion, probably you need to put something more in the middle, in this kind of puzzle. Because as I told you before, it's really important that you put in the surface of the printed electrode something that recognizes block molecules. You need to put other things together at the activated carbon. I think it is a valid support, of course, and in my opinion, it merely to be considered in future development. But you have, as I understood, you have to have very clear what you want to measure. One thing I learned along these years is that for know how I can measure something, I have to know the process that gives me that. In this way, you can, of course, have the support, the very good support, but probably, maybe it is enough, but probably you can need another material together with activated carbon. But anyhow, for me, it is valid support.
Very interesting talk. I have not seen structural characterizations, particle size, crystallographic structures are elements very important in catalysis at nanometer level.
They are very important if you put inside of your ink, intelligent ink or something else. Why? Because in the first case, for example, with the CO2 laser, you obtain a very heterogeneous surface. And of course, you obtain a very an increasing of the active area. In the second one, when you use particles, nanowires, nanotubes, etc., you probably are working with a structure quite different with respect to the first one. And they are important because, for example, like in my experience, when I use copper nanowires, for example, not only increase the active area, but copper is a good catalyte for nitrate. So you have two advantage from one structure. It depends what you want to use, but of course, they increase the active area and they are a good support for catalysts. Yes, you're welcome.
Okay, thank you very much. Thank you for your very nice talk. I just wanted to know, it's very interesting, the idea of having a liquid crystal to template the electrodeposit of silver. However, as far as I understand, liquid crystals are very sensitive, or the structure is very sensitive to electric fields, right? So when you're doing the electrodeposit, does that change? Do you have a dynamic change in the liquid crystal structure, and does that affect the electrodeposit structure?
After deposition, you mean? During deposition. I made the deposition with chronocoulometry. So, yeah, I fix some values, and to be honest, from my experience making depositions with many different methods, this is a very good method, in my opinion, because you follow the charge and current. Yeah. It is really important that you have a very parameters very constant, and this is one of the good choice for do it. Welcome.
Thank you, Doctor. Thank you for the presentation. It was very informative. My question is, what kind of interaction have the pollants, in this case, the allocetic acid, with the nanomaterials in the silver? And my second question is it difficult to remove those pollants after the treatment? Or
One question for first question.
what kind of interaction have the pollants with the nanomaterial?
Okay, you have to. Let me see if I understood your question. When you make dehalogenation by reduction, you have a concerted mechanism. And of course, it lets that silver acts like catalytic, and you reduce and remove chloride. This is the idea, is the remotion of chloride. The second one?
Yes, is it difficult to separate after the remotion the pollants from the nanomaterial?
You mean the chloride from
yes.
I think yes. And I don't know how much, but I think yes, because one of the protocols we prepared to keep these electrodes in good condition, and of course, don't give memory effect to the second measurement, because you have to consider also this. And the idea was keep this electrode in good conditions, in solutions that remove chloride, of course. No. It was one of the first problems in my mind that I considered, just to avoid memory effect in the second set of measurements. Of course.
Okay, thank you very much.
Well, I may have one. In addition to haloacetic acid, do you have any other, what has been the most challenging water or wastewater pollutant for you to work with?
I think that water pollutants are challenging in every case. Maybe if I have to give an idea, or maybe pesticides. Pesticides, even, or especially if you obtain samples with the shallow water, where you have a kind of resuspension of fine particles from sediments. And probably if you filter everything, maybe you remove. But pesticides could be. And of course, I have experience also with atmosphere particles, and they are also so challenging to remove. And honestly, I don't think there is one or one more challenging than another one. But you have to keep in mind one thing, that it was I put in one of the slides. Natural organic matter, it is a very strong vehicle that could bond whatever kind of pollutant, and especially, and I remember now some work of my PhD, I worked with humic substances. Humic substances has many characteristics, but they have three that they are very, very strong, and I say that it is impossible to remove a lot of pollutants when you have to consider them. They are a good chelator. They have hydrophobic sites, and they move in agreement with the chemical-physical equilibrium inside of the well. So, in my opinion, natural organic matter, more than pollutant, is, in my opinion, an aspect, a factor, or a component of environment that should be studied, because it is very, very, it can modulate whatever kind of interactions with pollutant. Sure.
And probably AOPs can also help degrading that organic matter to liberate the pollutants and then facilitate the analysis.
Yeah, for that reason, I told you, for us that we made sensing, we don't know nothing with respect to people here. Abatement, it is really important for us, because when we know the mechanism of abatement of pollutant, we have an idea what this pollutant in the environment has moved, or what is the behavior they have. I think, yeah.
I think we have a few more minutes, so maybe you can share your experience with the analysis of PFAS, electrochemical detection of PFAS, which are like very important environmental pollutants.
In the region where I live, we are a case study in the world, not in my region, in the world. Why? because a factory that produce manufacturers for to do clothes and so on, they emitted in water as nothing PFAS in quantities, in very big quantities. What is the problem in our region? You emit in water. If everything goes well, this go to the river and maybe you see in the sea, but no. Why? Because we have upwelling waters. Upwelling waters means that if you emit this kind of PFAS or whatever or another pollutant in this water go in soil and then move in upwelling kilometers on. And this means that you have this pollutant spreading everywhere. You imagine that environmental association made a very strong battle to to stop this one, make the conference, they make some kind of public accusations for this factory and so on. But you imagine they risk to be in the jail to do that. When the thing changed, when the authorities saw in the blood of younger people PFAS, because PFAS is, how can I say, it is not like PCB that interact with lipids, but interact with hemoglobin. For that reason, when they saw levels incredible in the water of, in the blood, excuse me, of young people, the play changed. And the play passed to environmental associations. But yes. And I don't, you remember the map I showed you before with the red part? This is the area of between Vicenza and Verona that was very, very under attack about this kind of compounds. Yeah, unfortunately.
There's no more question there.
Yeah, thank you. Very nice talk. I would like to ask you, in some of your calibration plots, you included zero values. In some others, you didn't. For me, the zero values of your calibration plots, in some of them you included, in some of them you didn't. For me, it is not clear the criteria.
What do you mean exactly?
The zero micrograms per liter, the response in some of your plots, they are not present.
You
in
mean
some.
alloacetic acid?
Yep.
We are how can I say? We are checking data and we are making. You mean exactly if to zero I have some response?
Yep.
No.
Or the criteria.
No.
In order to include them or in order not to include them?
In zero, we don't have any peak.
Okay.
No. No. And I told you when we made these 5 times measurements complete, when the electrode arrived at the end of its life, don't give you any signal. Stop.
Okay.
And this signal is associated with the reduction and dehalogenation, of course. Where is difficult to see when you have very small quantities, of course, this is clear, but we are moving to make a kind of protocol to measure, maybe with the artificial intelligence or something else, to have a fingerprint about. Okay.
Thank you very much.
Okay, and we have one last question, now that you're here all the way from Venice. Maybe you can say something about, have you worked on the detection of byproducts, degradation byproducts during AOPs treatment?
No, not exactly, but it should be very interesting. Why? Because we applied for European projects, and in European projects, when they are focused on the water quality and all the standards that have to be respected for this kind of treatment, could be very interesting. For example, check with some sensors if there are some
toxic byproducts,
toxic or some remaining products, or if you can, for example, you can make a trap for some kind of chemicals, and you can detect it in this trap. Could be an idea. There are many ideas that we have in mind, because we want to apply this kind of criteria for inline and online detection with the sensors, of course.
Well, thank you very much for this wonderful talk about the applications of electroanalytical chemistry for AOPs. And yes, we have a small present for you. Thank you for your talk. And now I think we have coffee break until 11:30, so you can have some coffee, cookies, fruits, whatever, and see you back in 30 minutes, please.